So, in our previous sessions, we were discussing about multiplexer related problems, and let me share my screen also. Any doubts or any queries in the previous sessions? So, basically, we have discussed about these problems where we have seen how to come up with higher order multiplexers using lower order multiplexers, and we have covered 4 cross 1 using 2 cross 1 and 8 cross 1 using 2 cross 1 and all these particular problems. And we are left with developing 10 cross 1 using 5 cross 1. Okay, so this is what we are going to discuss in today's session. Yeah. So any doubts or any queries in the previous sessions? Okay, so let us start with this session then. So in this particular session, let us try to develop a 10 cross 1 mux using 5 cross 1 mux. Okay. So if I want to design a 10 cross 1 using 5 cross 1, right? Now, first of all, 5 cross 1, it is going to have 3 select lines and it is going to have 5 inputs. Okay. That we should be careful over. And I'm going to have a particular 5 cross 1 mux with 3 select lines from inputs from I0 to I4. That is 5 inputs, right? Now I'm going to first of all come up with the truth table of my 10 cross 1 mux. It is going to look like this. I'm going to write it down. And 10 cross 1 mux is going to have 4 select lines S3, S2, S1, S0. And this is my output Y. So 0, 0, 0, 0, 0, 1, 1, 0 and 1, 1, 0, 0, 0. And over here 1, 0, 0, 0, 1, 1, 0 and 0, 0, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. And finally, I'm going to have 1, 0, 0. This will be my I9. From I0 to I9, I will be having of my 10 cross 1 box. Okay. Now, I need to find out the combination so that I can come up with the 10 cross 1 mux. So here I can see for a 5 cross 1 mux, I'm going to have, if I can able to see over here, I'm not going to consider this S2, I'm only going to consider this S1 and S0 so that I can have this combination 0, 0, 0, 1, 1, 0 and 1, 1. So that it is basically covering 4 combinations. Okay. That is I0, I1, I2 and up to I3 it is going to cover. Okay. Now, again, the pattern is getting changed 0, 0, 0, 1, 1, 0, 1, 1. So I can consider this 0, 0, 0, 1, 1, 0 and 1, 1 and I can connect I4, I5, I6 and I7. Okay. Did I miss any combination? 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1 and 1 triple 0 which is I8, sorry, and followed by 1001 which is I9. Yeah, and finally this last combination that is I9. So I'm going to have basically 3 5 cross 1 multiplexers in my stage number 1. So I'm going to have one 5 cross 1 mux and another 5 cross 1 mux and 5 cross 1 mux like this. And what I'm going to do in this 5 cross 1 mux, I'm only going to consider S0 and S1. S2 I'm going to make it as 0. Okay. So S2 I'm going to consider it as 0 for every 5 cross 1 mux. This S2 is equal to 0 and this S2 is also equal to 0. I'm only going to consider this S1 and S0. This is my S0 and this is my S1. Okay. And all the inputs from I0 to I9, I'm going to connect it. Now, coming to the next stage. So, in the next stage, I'm going to consider this set of select lines. Next 0, 1, next 1, 0. Okay. So, I'm going to have only one 5 cross 1 mux for this in the next stage, where as the select lines, I'm going to consider S3 and S2 as my select lines, S3 and S2 as my select lines, and S1 I'm going to make it as 0. So what I'm going to do is I'm going to consider S3 and S2, and S1 will be equal to 0. And I'm going to take the output from here, this output and this output. So what is that I'm going to get? And remaining two outputs will also be equal to 0. For a 5 cross 1 mux, we are going to make our remaining two outputs also equal to 0. Now what is that I'm going to get? Let's say suppose if S3, S2 is equal to 0, 0, then depending upon my S1, S0, I'm going to decide from I0 to I3. And if S3, S2 is equal to 0, 1, from I'm depending from I4 to I7. And depending upon my S3, S2, if it is equal to 1, 0, then I'm going to choose from I8 to I9. So this is how I'm going to basically design a 10 cross 1 using a 5 cross 1 box. Okay. Is it clear for everyone? Any doubts or any queries? Please look into it and let me know. So this is how we are going to build a 10 cross 1 box using a 5 cross 1 box. Okay. Yes. Is it clear? Any doubts or any queries over here? Okay. That's fine. So we have came up with the solution for 10 cross 1 using 5 cross 1. Now, let's say suppose if I want to build a 10 cross 1 using a 3 cross 1. Okay. So I want to build a next one. I'm going to come up with 10 cross 1 but using 3 cross 1. So I can say again take the same table for this. So I'm going to take the same table. But in the case of my 3 cross 1, I'm going to have only two select lines. Okay. And I can basically have only three inputs that can be connected. Okay. So I'm going to take the same thing. Let me erase it. Now, in the case of my 3 cross 1 mux, I can have only three inputs. Okay. So that means 1, 2, 3. This combination I can consider. This is one 3 cross 1 multiplexer. Next, I3, I4, I5 I can take, but if you can see in 3 cross 1 multiplexer, I will not have the combination S1, S0 to be equal to 1, 1. So I cannot take this combination, right? So if you consider your 3 cross 1 multiplexer, if you get 1, 1, your output is not valid because you are going to you are going to take a 4 cross 1 mux and you are going to convert it into a 3 cross 1, right? So S1, S0, if it is equal to 1, 1, it should be equal to 0 because you are grounding the fourth pin. Okay. So that's the reason this particular combination is not at all present. And if this combination you are going to get, you are going to make your output to 0. You cannot consider this 1, 1 combination. Okay. And what else you have? Again, you can start from here 0, 0, 0, 1, 1, 0. Okay, and you can have I3 present over here, I4 and I5 present over here. And again, you should skip this particular combination because we cannot have this combination which can be implemented using a 3 cross 1 mux. And coming to 0, 0, 0, 1, and one more combination is 1, 0, 1, 0. Here, this will be connected with I6 and this will be connected with I7 and this will be connected with I8. So like this we are going to consider. So what I'm going to have a 3 cross 1 multiplexers like this. This is 3 cross 1, 3 cross 1 and 3 cross 1. Okay. And I'm going to have I0 to I2 connected. I0, I1 and I2 and I3, I4 and I5, I6, I7 and I8. Okay. And here I'm going to connect my select lines S1 and S0. S1 and S0. And the other input is obviously 0. So if your S1, S0 is equal to 1, 1, you're not going to get them. And this will be given to your one more 3 cross 1. And this will be connected to your S3 and S2. Select lines will be connected to S3 and S2. And here you are going to get your output. Let's say suppose S3 S2 is equal to 0 0. You are going to depend upon S1 as S0 for getting your output. And let's say S3 S2 is equal to 0 0 and S1 S0 is equal to 1 1. This combination cannot be occurred. So if S1 S0 are equal to 1 1, your other pin is grounded. In a 3 cross 1 mux, S1 S0 can reach up to 1 0 only. S1 S0 cannot be equal to 1. Okay, that we are skipping and we are providing 0 to my output. Okay, so like this we are going to build a 10 cross 1 using 3 cross. Okay. Yes. Is it clear for everyone? So this is how we are going to come up you building 10 cross 1 using 5 cross 1 and 10 cross 1 using 3 cross. Okay. Now, so this was about my 10 cross 1 using 3 cross 1 and 9 cross 1 using 3 cross 1 also the same method you can implement. Now, let's say if I want to implement a 6 cross 1 using 3 cross 1. So let's first of all come up with the 6 cross 1 table. 6 cross 1 using 3 cross 1. So in the case of my 6 cross 1 using 3 cross 1, I'm going to have again three number of select lines S2, S1 and S0. 0, 0, 0, 1, 1, 0, 1, 1. These are my four inputs and 1, 0, 0, 1, 0, 1. Okay. And this is I0, I1, I2, I3, I4 and I5. Now I need to come up with a 3 cross 1 multiplexer. So these are the three combinations which I have, and I cannot have 1 1 in my S1 and S0, and so that I'm going to take one more combination. So let me write it down over here. S2 S1 S0 0 0 0 0 0 1 0 1 0 0 1 1. S1 and S0 cannot be equal to 1. Okay, because if you are going to make it 1, you are going to provide your output is equal to 0. In 3 cross 1 mux we don't have select lines to be equal to 1. So I'm going to have I0 connected over here, I1 and I2, and here I'm going to connect 0. And next for 100, I'm going to connect I3, and for 101, I'm going to connect I4, and for 110, I'm going to connect I5. Okay. Now for this, what I'm going to do, this is one pair, and this is one more pair. Okay. So I'm going to have basically three 3 cross 1 multiplexers, where in the first stage I'm going to have this 3 cross 1 mux, and in the next stage I'm going to have one 3 cross 1 mux, where I'm going to have S1 and S0, and from I0 to I2 is being connected over here, and I3 to I5 is connected, and one more 3 cross 1 mux, where the other two inputs are grounded, and you're going to take over this particular inputs, and you're going to have S2 and S1. So if S2 and S1, if it is equal to, okay, no need of S2 and S1 also. You can basically consider simple S2 itself, and S1 you can make to ground. So depending upon your S2, okay. So here you can consider your S1 as equal to 0 as your MSB, and S2 you can consider, or else we can reverse it. What we can do is S2 S1 we can consider 0 0. We can consider S2 as MSB, so that we will have this combination. So if H2 is equal to 0, we are going to consider the inputs of this multiplexer, and if H2 is equal to 1, we are going to consider the outputs from this particular multiplexer. Okay, yes. And H2 is not equal to 0, S1 is equal to 0, and depending upon H2 only, we are going to consider my outputs. Let me erase it. Yes. So this is how we are going to build a 6 cross 1 using 3 cross 1. Yes. Please look into it and let me know. Yes. So this is how we are going to build our higher order multiplexers using lower order multiplexers, where we have discussed about implementing all the particular higher order multiplexers using lower order multiplexers. And you can basically apply the same methods for implementing all these particular remaining implementations also. Okay. So in this multiplexers, as I've said you, we have discussed about all the problems which can be possible using this multiplexers, like logic gate building using this multiplexers and higher order multiplexers using lower order multiplexers. So two set of problems we have discussed it. And in the third set of problems, we are going to have some gate related questions that also we will be covering, so that in interviews you can basically it will help you to crack your interviews, right? So first, what we will be having is tomorrow I will be sharing you a Google Form link, and you can basically access that particular Google Form link. And time limit will be 30 minutes. You can first try to solve those particular problems in 30 minutes, and then day after tomorrow, that is Thursday, we will have a session. Or else tomorrow, like depending upon, I will keep a poll like when everyone is available, so that you can write down your test. And tomorrow, if possible, we will have a session and we can discuss the solutions. Okay. Yes. So that's about this particular session. If you have any doubts or any other queries, you can discuss with me, or else we can wrap up the session. Okay. Thank you.